Hello everyone, and welcome to the Introduction to Python workshop, brought to you by Next Step Hacks and 𝗡𝗲𝘅𝘁𝗲𝗀. So I'll be starting with the basics of Python, how everything works, and slowly progressing through the various features, syntax, and how everything is supposed to work throughout the language. And at the end, you'll have an idea of how to get started with some sort of application that you develop using Python. So to get started, let's talk about Python in general. So Python is an object-oriented, pretty modern language that was developed for enhanced readability and was developed as an interpreted language, which means that unlike compiled languages, Python is special in that every single line is interpreted by the compiler in real time, which basically means if I have a bunch of lines of code, for example, although this isn't proper Python syntax, but if I had certain lines of code, the Python interpreter, when I run this file, would go through each line, execute the line, and then move on to the next line. And once it reaches the end of the file, or after all its instructions are complete, it just stops. So to get started, the basic element of Python that you'll need for anything you do is called a variable. Now, you might know this from another programming language if you've had experience with one, but a variable is basically a memory location that stores a certain value. So say you want to store the value 2 somewhere, like the number 2. And so if you store the value 2 into a specific variable called x, whenever you refer to this value x, you'll be referring to the value 2. So you can store any sorts of values into these variables. They're basically like containers that are spread throughout the memory of your computer, which you're running this Python script on. So what's basically happening is it understands this line as take the value of 2 and store it somewhere inside this giant memory location that I have. And then whenever somebody references x, provide them the value of 2, which is inside that specific memory location that I put it in. So another important statement that you will need for debugging is the print statement. Now, to print anything in Python, you use the statement, and it basically displays whatever value you're putting into it into your console whenever you're running the file. So now I can print x. This is a very basic Python line. I'm setting the value of x to be equal to 2, and then when I run the code, I'm printing the value of x. Now the interpreter, which I talked about, is going to first interpret line 1. I'll remove this extra line. The interpreter is first going to interpret line 1 and set the value of x to the memory location and set that memory location's value to 2. Now, in the second line, I'm calling a special, this is called a Python inbuilt function, and I'll get to functions later, but for now, you're basically telling Python to print something to the console, and inside these two curly braces or parentheses, you're telling it what to print. So I can put anything in here, like I can directly put 2 or 3 or anything in here. For now, I'm putting x. Now, whenever Python sees the value x, now it remembers that x was set to the value of 2 previously. So it figures out what x is set to and replaces the value. For in any legal place where you put x, it'll replace the value with whatever x is defined. And if you never set x to anything, like if I tell it to print y, it doesn't know what y is. So it's giving me a red underline saying the name y is undefined. But x is defined because I told it what x is equal to in the previous line. So, therefore, when I run this code, it's going to set x to the value of 2, and it's going to print the value of x. Now, ideally, if you would want to run a script like this, what you would do is, if you have the file, in this case, the file is main.py inside your terminal directory, you would be able to run the command python main.py. Now, for this, obviously, you'll need Python installed. To do that, you can head over to python.org and download the specific Python version for your operating system. For me, I'm running this on Replit, which is an online IDE for lots of languages, and one of them is Python. this basically gives you a development environment and lets you preview your code, run your code, and do all sorts of things with it. So if you are working on your computer and following along with this live stream, you would be able to run this command to execute any code you have. Remember, Python is the name of the Python interpreter. You're basically referencing the installation of Python when you call this. And depending on your operating system, you might need to add a 3 at the end, because you might need to reference the fact that we're using Python 3 or Python version 3 instead of Python version 2. Python version 2 was discontinued a while ago, and although it's still it's not available for like it's not commonly used, it is available, and some operating systems have it installed. So you might need to specify Python 3, and in some other cases you might need to use py, depending on how Python was installed in your computer. But for Replit, it generally uses Python. So if you run this command, python main.py, it will run your file main.py. Now, obviously, so Replit has a cool feature where it lets you run files. So if I click the run button, it's going to do the same thing and print out the value too. Now you can see here, it goes line by line at x equals 2. It sets the value of x to 2, and then it goes to the second instruction. The second instruction says print the value of x, and x is 2, so x is printed, the file is over, and everything stops, which is why the run button is back up again. Now, you couldn't use a debugger and other things to verify that this is how it works, but that is how it works, and I'll get into other stuff like this later. So something that's super important about Python that I'll get into later, it'll be more important later, is where variables are accessible. So Python has, and most of the programming languages also have, this thing called scope, which is where variables are accessible by other things. So, for example, the variable x is not accessible in any place other than throughout this file. So if I'm like out of this file, whenever this file starts running, it runs this line. It sets x equal to the value of 2, which means it's creating a memory location somewhere inside your memory of your computer. It's putting 2 inside that memory location, and then it's creating x in your code as a reference to that specific location. Now, once this file is done, right, now it's passed the first line, it's printed the line, and now it's over here. When your interpreter is over here, now it'll realize the file is over, and now it'll think, we don't need to access x anymore, because x was defined in this file, and now x doesn't matter anymore. So it's going to think about where x is, that specific memory location, remove 2 from it, and make it open again to other data, and then it's going to clear the value of x and then move on. Now, there are specific commands like functions and classes which will require you to define new variables, and variables defined within these will not be accessible outside those specific functions and classes, but we'll get into these later. For now, just remember that this x value and the value of 2 will not be saved in your computer, because if it is, and every time you run something, it sets 2 into a specific memory location, your memory would be full by the time everything's over. So once like a variable isn't in use anymore, it's deleted. Now we'll talk about one of the like basic conditional statements of Python. So a conditional is basically if. Like that's the best way to explain it. If something is true, then I do something, and if it isn't, I don't. So think about it like, if the weather is sunny, I'm gonna put on a t-shirt. If not, I'm gonna put on a jacket, for example. So Python also has a feature like this, which basically lets you execute a line of code, like how this line of code is executed and this line of code is executed. It lets you execute a line of code only if a specific condition is true. Now, we talked about variables before. There are different types of variables. For example, 2 is an integer. An integer is just a number, basically. A number without a decimal place. So it could be stuff like -1, 5, or 1,000, or any of those are valid integers. There's also a data type called a string. To define strings, you either use single quotes or double quotes. And as you can see, the replet IDE automatically fills in the second double quote because it recognizes that quotes are special and signify strings. Now, within these, I can put any sort of jumble of letters, like welcome to this workshop. True, backslash, not backslash, forward slash, left-hand side. You can put any sort of characters in here except for special characters. These special characters are things like backslash, which will obviously cause an error because I'm using it incorrectly. Another quotation mark within it. Now, this quotation mark will cause an error because the way Python recognizes a string is over is through the ending of a quotation mark. So now if I have an extra quotation mark after it, now if I have a quotation mark in the middle of a string, for example, like this, now Python thinks that the string, which is highlighted in orange, ends over here. And now it doesn't know what to do with the rest of this. So it's getting mad and throwing errors. So you can't use special characters like that. And remember, if you're defining your string with double quotes, you're free to use single quotes in the middle of a string. If you're defining the string with single quotes, you can use double quotes in the middle of a string. That's why there are two different and actually more ways to define strings. That's because it makes it easier for you to add single quotes and double quotes within the string without escaping them, which is a very advanced concept. Now, there's also something called a Boolean. A Boolean is just true or false. So I can set this to true. As you can see, it's highlighted because it recognizes that as a Boolean. Now, x is the value of true. If I run this again, when it prints x, it'll print true. And the opposite of true is false. Now, Boolean values are the basis of if statements, because if statements compare whether if something is true, it runs a command, and if whatever is false, then it does not run the command. So let's think about it this way. Let's set x back to 2 and say if true, print x. And I'll remove this original print x over here. So what this is the basic syntax for an if statement. You have a keyword. Where I'm putting if is a keyword. Now Python has a lot of keywords. For example, for, it's highlighted blue. While, it's highlighted blue. And other things like these are keywords. They're not functions. They're just keywords recognized by Python that make it easy for you to do anything. And this means you can't name any variables keywords. Like you can't say if equals 5 because if is a special keyword. So you should keep in mind these specific keywords. For example, ID is a specific function in Python. So you cannot set ID equals 2. It will not run. That's why you generally would prefer to use ID underscore. Now, back to the if statement. How it works is you have the keyword if, signifying that this line is starting an if statement. And then you have an opening parenthesis, and then a closing parenthesis. And between these is the expression you want to evaluate. So wherever this true is where you would put it is sunny outside. If it is sunny outside, then I want to do this. Is basically how an if statement works. So right now I have it set to if true, which basically means if the value inside the parentheses, and how if evaluates it is if the value inside the parentheses is true, then I'm going to actually execute whatever is in the next line. And if this value over here is false, then it knows I do not want to execute this, and it's going to move on to line 5. Now I'm going to be referencing lines by these numbers on the side, which is a common practice because instead of defining the line where x is set to 2, you can just reference this specific line as line 1, and then now you'll know exactly where that line is located. Now, basically, in line, if the if statement is if the expression inside the if statement is false, then Python will understand that you do not want to execute whatever is inside the if statement, and it'll move on to line 5. So it'll check line 3, skip line 4, and then move on to line 5. And as you can see this, it'll set x equal to 2, but when I run it, it does not print anything. It's just blank. If I put a true inside this expression, it'll always execute line 4 because inside the if statement, there's a true, and true means the if statement checks whether that expression inside the parentheses is true. So now 2 will be printed out. Now, obviously, this isn't a great approach because every time you want to check something, you don't want to use true inside here. You'd want to have a specific condition. Now, Python has a bunch of conditions you can use for this. And these are similar to what you've learned in math, similar to like x is less than 2, x is greater than 4, x is greater than or equal to 2. Since you don't want to put a greater than or equal to symbol within Python, you just append the equal to after the greater than, and that works. Now, these are special operators that Python uses for comparison. If you evaluate x is greater than or equal to 2, this will return a Boolean, which is true or false, as we talked about. So if I specifically print the value of x is greater than or equal to 2, now when I run this, and I made this false, so this print statement does not execute. So basically, it's going to run these lines. If you print x is greater than or equal to 2, you'll see that it's true because x is greater than or equal to 2. Greater than or equal to is basically checks if the value of x is greater than 2 or if the value of x is equal to 2. So now you can see that this entire statement becomes a true, and that is why the print statement prints true to the console. Now, there are other comparison operators that I haven't gone over, but you can basically substitute all of the less than or equal to and greater than or equal to, just like how they would generally work. There's a special operator called equal. Now, you might remember that when we set a variable to something, we use a single equal to sign. And this means you're setting the value of x to the value of 2. But now, if you just try to run an if statement using x equals 2, it won't let you, because it's basically trying to get whatever's inside here to become a Boolean, true or false. Now, x equals to 2 is not a true and it's not a false. It's doing something completely different. It's not giving you a true or a false. It's just setting a value. So it doesn't like that. And as you can see, the error is invalid syntax. Now, if I put 2 equals, now this entire statement isn't setting the value of x to 2. It's checking if the value of x is equal to 2. So basically, if x is equal to 2, line 4 will run, and if x is not equal to 2, then line 4 will not run. The opposite of this, not equal to, is an exclamation mark equals. Now, generally, in most programming languages, an exclamation mark symbolizes not. And this is also true with Boolean algebra and other logic operators. The exclamation mark generally means not. So you're basically taking an equal to sign and then inverting it to become not equal to 2. Now, this expression will become false because x is equal to 2. And this is checking if x is not equal to 2. And this specific expression is false. For example, if I run this now, it won't print anything. But if I say x is equal to 2, x is 2. So this if statement will evaluate to true, and line 4 will be executed as a 2. Now, you might notice that after the if statement is defined, the line within the if statement is indented. Now, indenting can be any number of lines. Some people prefer to use 2 spaces when they indent, and some people prefer to use 4. I'm using 4 for this specific example. So basically, this means that whatever lines are indented by 2 or 4 spaces or whatever you choose will be within the if statement. So if I have some code like this, basically, all these 3 lines are within the body of the if statement. So if this if statement evaluates to true, it will run all 3 of these lines. And if this if statement evaluates to false, it will skip these 3 lines and move on to line 7. So if x is equal to 2, this is a true expression. So now it's going to print the value of x, which is 2. It's going to print the value of x plus 2, which is 4. and it's going to print the value of x minus 2, which is 0. And then it's going to print x, which is 2. And you can see that's what it prints. Now, if I make the if statement so that these three lines, lines 4, 5, and 6, only run if x is equal to 3, now 2, 4, and 0 will not be printed, and it'll skip straight to line 7, where 2 will be printed. And as you can see over here, 2 is printed. Now this is how you make multi-line if statements, where you chain them along. And as you can see, this colon at the end is what tells Python, okay, I'm done with this expression, and now I'm starting an indented block of however many spaces you choose. And as long as the indented block goes on, all the lines within the indented block will fall under this specific keyword, which is if. And you'll see this pattern repeated for other things we go over in the future, like loops and functions. So that's basically how if works. Now, what if x is equal to 3, you want to print x, but if x is not equal to 3, you want to print x plus 2. Now, what you would ideally do for this, based on what you know, is if x is equal to 2, you print x plus 2. Now, what this is basically going to do is, if x is 3, it's going to print x, and if x is 2, it's going to print x plus 2, which is 4. Now, this works for this specific example, because x can't be 3 and 2. But what if, and I'll just run this to make sure that's what happens, it only prints 2. It only prints 4, because x is equal to 2, so line 6 actually runs, and x is not equal to 3, so this expression is false, so line 4 is skipped. Now, what if you want to run something if x is not equal to 3? Well, if you're using an equal operator, you can do this. And this is completely valid. If x is equal to 3, it runs this, and if x is anything but 3, it runs this. But if you're using something like greater than or equal to, or you just want a shortcut for this, or you're using variables, or some complicated expression within here that you just want to say the opposite of, then there's another special keyword called else. Now, else doesn't have any parentheses, unlike the if statement, because else has no expression. Else is just, if the if statement that's right above it does not run, then the else block will run. And you might see me using these, using the hashtag symbol along with a specific comment. This hashtag symbol symbolizes a comment. A comment means as soon as Python sees this hashtag, it will ignore the rest of the line. So this entire line is ignored. This entire section and this entire section are ignored. And I can also make lines like this. If statement. This entire line is going to be ignored because as soon as Python starts reading line 3, it's going to read the hashtag, and then it's going to ignore until the rest of the line, until it gets to line 4. And in line 5, it's going to print the value of x, keep reading, and then it sees the hashtag, so it just skips the rest of the line, does not execute anything, and moves on. These are just to show you what the value of this would be, and they're just for readability purposes. You'll see these a lot on documented code, similar to that are meant for sharing. So if somebody writes some specific lines of code and multiple people are working on the project at the same time, they would generally use comments to tell other people what their part of the code actually does, so they actually know what's going on. You'll see me using these just to explain what's going on. Now, this else statement will run x plus 2 if the if statement does not run. So obviously, if you have an else statement by itself, Python will not recognize it because it's invalid syntax. It needs an if statement before the else statement for the else statement to actually be correct. So if x is equal to 3, it's going to print 2. If x is not equal to 3, then it's going to print 4. If Python figures out this expression is true, it's going to run line 5. And if it figures out that this expression is false, it's going to run line 7. That's how an else statement works. So for right now in our example, x is equal to 2. So if x is equal to 3, this if statement evaluates to false. So the so it will not print 2, and it will instead move on to the else statement and print 4. As you can see, it prints 4. So that's how if and else works. If something, do something, and if that something is not true, then do something else. Now, where the else really comes in is if you have multiple chained if statements. So if x is 3, I want you to print x. If x is 4, I want you to print x plus 2. If x is 5, I want you to print x plus 3. And if x is anything other than 3, 4, and 5, then I want you to print x minus 2, for example. Now, you could ideally do this using multiple if statements, like if x equals 4, do whatever, and so on and so on. But where the else really comes in is with the use of else if. So else if is basically a chain in between an if and an else. It's called an elif. Now, an elif is like an else statement, but it has a condition. Now, let me write this line really quick. So now, this specific part of the code is basically checking if x is equal to 3, I'm going to print 2. If it's not equal to 3, but it's equal to 4, I'm going to print 0. And if it's none of them, I'm going to print 4. That's basically what this is checking. So obviously, the printing x and x minus 2 and x plus 2 is like pretty vague. So I'm going to print something like x is 3. And if x is 4, I'm going to print x is 4. And if it's none of them, I'm going to print I don't know what x is. Although obviously it does know what x is since it's saved in the memory location. But say this is something that only recognizes x as 3 and 4. This could be useful in things like website like fields, where it only wants x to be either 3 or 4. And if it's none of them, then it needs to tell them to make x 3 or 4. Obviously, this is like a very vague example, but here we go. So if x is 3, it's going to print this. Else, if x equals 4, it's going to print x is 4. Else, it's going to print, I don't know what x is. Else is basically like a if not. You can think of it that way. So now x is 2, which means it's going to go to line 4. If x equals 3, it's going to say, okay, x is not equal to 3. So I'm going to ignore every line after this that's indented. So I'm going to ignore line 5. Go to line 6. Else if x is equal to 4. So we already figured out x is not equal to 3. But is x equal to 4? No, x is not equal to 4 because x is 2. So it's going to skip line 7, which is the only indented line, and move on to the else. Now the else catches everything else. So x isn't 3 or 4, so it goes into the else statement where it says, I don't know what x is. And let me remove these comments because they are not necessary right now. But basically, that's how the flow works. So now, right now, it will print, I don't know what x is. Now, if I change one of these conditions to x equals 2, what it'll do is it'll say if x is equal to 3, it isn't. So I'm going to skip line 5. Else, if x is equal to 2, now x is 2. So using the current x equals 2, it's going to say the expression inside line 6, x is equal to 2, will be true. So line 7 will actually run and print x is 2. Now, remember how if we just had an if and an else, if the if statement was true and the if statement ran, then the else statement will not run, because the else statement only runs if the if statement does not run. So now the else statement only runs if every single if and else statement returns false. So x equals 3 is false, but x is equal to 2 is true, so it will run line 7, skip line 8 and 9, because else is not valid right now, because line 7 has already been run, and it'll move on to line 10, where the file ends and the script ends. So now it'll print x is 2. That's how an if, else if, and else condition works through the sequential order. Now we can talk about loops. So you know how we're checking right now if x is 2, when x is 2, if x is 3 and 2. Nobody's going to define x and check whether it's equal to 3. Obviously, the only reason you would use this is if you have no control over what x is equal to. If x is equal to some value that's either given to you from like a specific form or like a text file or even defined by Python itself that you don't know, then that's where if statements really come into play. For example, if you have a text file that basically has the value 5. Now, you don't know what this text file is because somebody's giving you this text file. The main way you would figure it out is, say you do some statements which are pretty self-explanatory, and I'll go over them if I have time. You basically parse in this text file and then set x to whatever's in the text file. Now, the text file is 5, so x will become 5, but you don't know what x is. You don't know. Now, the only way you can figure out what x is through these if statements, where if x is equal to 3, if x is equal to 2, and so on. That's the only way you can run code specifically when x is a certain value. And this is also useful when you have a for loop. Now I'm going to leave this entire thing commented. Again, you can see how I'm using the hashtag before the entire line. Now, Python, whenever it reads any of these lines, it sees the hashtag, so it doesn't read the entire line because it's a comment. Now, what happens after an if statement is you can have something called a for loop. Now, we define a for loop in the same way as we define an if statement. For, and then we're going to have some stuff in here that I'll fill in later. You have a colon, which is basically defining, you're starting a new code block. Now, other languages have a different way of defining this code block. As we saw in the if statement, this colon defines a code block, and everything inside the code block is indented. Now, some languages like Java use something like this. For, obviously the condition goes in here. They have an open curly brace, and then anything between this curly brace and this curly brace is within this for loop command. Now, Python uses indents, as we talked about. So if I have this colon, now it's auto-indenting for me because it realizes the colon means the next few lines are indented. Now, you can run any sort of code in here, and then once you stop your indent and then start running code in here, that's when it knows that the for loop is over. So that's the general structure of any code block you see. So now, to define a for loop, you need a variable you're creating. So generally, convention for any sort of numbers you use is I. I don't know why, but it's just commonly used. So for I in, this is the basic conditional part of the for loop. So you're basically saying, I'm creating a new variable called I, and that value I is going to be in the range of 0 to 5. That is how Python interprets this. Now, obviously, this range part is what you will generally change. This is your variable, and this is what the variable will go through the cycle of. So here I can define a list, which is another data type that you could have assigned x to, and I can make x 1, 4, 7, and then 10. Now, when this for loop runs, I will become 1, 4, 7, and 10. I think you see where this is going now. So a for loop basically runs whatever is inside the for loop multiple times where I is defined as one of these 4 values. So, for example, if I just do a basic print I within this for loop, and then unindent back, and then print 2 dashes just to signify the end of the file, right? What it's going to do is, with I going as 1, 4, 7, and 10, it's going to print I, and it's going to run this line 12 4 times, where I is 1 on the first time, 4 when it's running the second time, 7 when it's running the third time, and 10 when it's running the fourth time. And obviously, this list will generally not be a list that you just make on the spot, like right here. You will, if you know that your list is going to be 1, 4, 7, and 10, you won't need to use a for loop because you can just print 1, 4, 7, and 10. This list will be given to you from external sources, like a website where they check off a bunch of boxes. And now, for every single box they checked off, you set that specific box into the value of I, and then run everything inside the for loop using I as the value of that one specific checkbox they checked. So now if you have 1, 4, 7, and 10 within here, it's going to print I when I is 1, 4, 7, and 10. And we can see that when we run the code, it'll print 1, 4, 7, and 10. And each of these is running while I is inside the for loop, and while we're inside the for loop, and I is assigned to each of these values. Now, I showed you range before. Range is basically creating one of these lists, which we have right here. Range is basically creating a list in sequential order. So if I start from 1, 5, the way range works, and you can see a sort of preview of how it works over here, return an object that produces a sequence of integers from start. So it's going to start at 1, and it's going to produce a sequence of integers. Remember, integers can't have decimal places. So it's going to produce 1, 2, 3, 4, and a special thing about range is it will not produce 5 because the final element is not inclusive. So if this was 6, it will produce a list of 1, 2, 3, 4, and 5. So this specific command will become this list. This is just basically a shorthand for if you want to define a sequential list. Now, this is how the for loop works. You can run anything inside this for loop. Again, you can have multiple lines within the for loop as long as they're indented, and it basically just goes through all of this entire range. For example, if I print I from 1 to 6, it'll print 1, 2, 3, 4, and 5, and then it'll print the 2 dashes. Remember, only everything that's indented, it falls inside the for loop. Now, something else you can do is called a while loop. A while loop basically checks while a certain thing is true. I'll get into that later, but now I want to talk about something else. When you're inside your for loop, remember how I told you the if statement is useful when you don't know what the value of something is? Now, obviously, one of the basic fundamentals of Python is you can stack blocks inside blocks. So right now, the if block comprises this section, and this if block is located within the for loop, which is also a block. So now, how Python's going to interpret this is for I in range of 1 to 6. So right now, I is going to be set to 1, and it's going to run everything inside the for loop, which is this. Now, inside the for loop, it's checking, is I equal 2? No, so I'm not going to run this. Is I equal 3? No, so I'm not going to run this. Now, since the for loop is done with its first loop, it moves on to the next value of I, which now it's not going to be 1, it's going to be 2. Now, when I is equal to 2, it runs this entire thing. Now, when it runs it with I equals 2, it's going to say, if I equal 2, yes, I does equal 2, so it's going to run line 13, and it's going to print I. And then, if I equals 3, it's not equal to 3, so it will not print this, and it'll move on. And now I will be equal to 3, and it'll print I again when it's 3. And then I will be equal to 4. It won't do anything because none of the if statements will actually evaluate to true. And when I equals 5, it will also not do the same thing. So basically from this, you'll get 2 and 3. Now to make this even more realistic, we can do something like, we can print do something, which is basically going to do something here and do something else. Now, only in this entire loop of 1 to 5, of I being 1 through 5, it'll only do something when I is equal to 2, and it'll do something else when I equals 3. Now, when I run it, you'll see do something and do something else. You'll see that because when I is equal to 2, it'll do something, and then I will become 3, and then the next time when it runs this entire block when I is equal to 3, the second if statement will run, and it will print do something else. That's what for loops are used for. Now, a while loop is pretty similar to a for loop in that it's a loop. While and for are generally the most common approaches for loops. So for this, I'm going to remove the x equals 5 statement up here, and I'm going to define a counter equals to 0. Now, an important thing that I forgot to mention about variables is how they can be defined. Variables are generally defined lowercase words. They can also be just letters or anything you want, right? But there are some exceptions. Obviously, they can't be keywords, and I mentioned that before. But one of the important things they can't be is they cannot start with a number. Now, the reason they can't start with a number is just because that's just how general variables are defined. They also can't start with special characters like stars, and any of these things are just it's just recommended to name variables with their purpose. For example, when I'm using X in my example, that is horrible practice when you're actually developing code. Because if somebody else is going to use your code, they're going to see the variable X and have no idea what X represents. And they're going to have to search through your code to figure out what you set X to and when you're setting X to something. And then say somewhere you're setting X to the value of an email that they enter in a form. If you set instead of setting X is equal to the email, if you set the variable email to their email, it'll be easier to know what a variable represents. So I should not be using X here, but I'm just using it for simplicity and for typing easier and demonstrating. So a while loop also requires a condition. So X is less than 4 is what I'll do. Obviously, you need the colon to define that it's a code block, and then now you have some code you can run in here. Print X. This is a basic while loop. So X starts at 0, right? Now, what this specific while loop is going to do is it's going to say, while the value of X is less than 4, I'm going to print the value of X. Now, I'm not going to run this for specific reasons in that, think about how the Python interpreter is going to interpret this. X is going to be 0. Now, while X is less than 4, which X is less than 4, it's going to print X. So it's going to print X. Is X still less than 4? It is. So it's going to print X, it's going to print X, and it's going to print X over and over and over again until it just goes on infinitely and the loop never ends. And then you're out of memory because you're running so many commands. So if I run this, for example, you can see that it just keeps on going forever, printing zeros, and you can see my entire terminal window is just lagging and glitching and everything. So I'll stop this right now because it has not been stopped. As you can see, when I run it, there's a stop feature because the script is still running. So if I stop this and I clear my console, that's why you should never do this. Now, I can do something like X plus equals 1. Now, this is basically a command that says X equals X plus 1. It's a shorthand. So basically what this does is, the way Python parses these commands are, right now when it parses line 13, it's going to say, what's the value of X right now? It's 0, right? What's 0 plus 1? It's 1. Now I'm going to set the new value of X to 0 plus 1, which is 1. Now the second time it goes through this loop, what's the value of X? 1. So it's going to say, this entire expression is going to evaluate to 1 plus 1, which is 2. And now you're setting X equal to the value of 2. And you're going to go on. So basically, this is sort of like your for loop, where you're going. So this is actually identical to the for loop where you're going for I in range of 0 to 4. This for loop is identical because this for loop is basically setting I to 0, 1, 2, and 3 and running the code inside there. Now what the while loop is doing is X starts at 0, you're printing X, and now X becomes 1, which is exactly what the for loop does. X starts at 0, you're running whatever is inside the for loop, and then it increments to the next value because that's what range does. It creates a list of 0, 1, 2, and 3. Now, obviously in the while loop, if X is 3, it's going to print 3, and now X is going to be set to X plus 1, which means X is now equal to 4. When the while loop runs again, it's going to realize X is not less than 4 anymore because X is now the value of 4. And 4 is not less than 4. So it's going to stop the while loop, move on, and print line 17. If I run this code, you'll basically see an output of 0, 1, 2, 3, and by the time it gets to 4, it can't print because now the while loop condition is false. This basically means every single iteration is checking the condition over again to see if it's still valid. As you can see, that's what it prints, 0, 1, 2, and 3. Now, a while loop is used generally if you don't know how many times or how long you want to go. Like, if you just want to go until a certain condition. Say you have no control over how x changes. Say x can just change randomly. And I could actually implement this, but I'm not going to right now. If x is, you have no control over it, and x is being changed by something else, like another file or another program, which is possible. Or x is just changed by the user. If you don't know what x is going to be, you just run the while loop until x becomes something that kills the while loop. But if you're using a for loop, you want to run a specific number of times, or you want to run from a specific range, or in a specific list. So that's what the two loops are for. You can make every single while loop a for loop, almost every single while loop a for loop, and you can make every single for loop a while loop. It's just a matter of which one is more convenient to use and which one will be faster and more efficient for the specific use case. So now I want to talk about modules. You see I have this file over here called module.py. Now, inside here, this specific set of blocks is a function. I'll quickly go over what a function is. I won't have much time to explain what it is. Def is the keyword for creating a function. It's supposed to mean define, like I'm defining a function. Now, within this function here, I have x. X is a parameter. A parameter means whenever you call this function, you're passing in a parameter. So if I would generally want to call this function, I would module function is a variable. Right now, module function is a variable. The define keyword makes module function a variable of type function. Just like how it can be an integer, a string, a boolean, true or false, it can also be a function. Now, a function has a special feature where if you put parentheses, you're basically calling the function, basically executing the function. A function is just some lines of code that are just grouped into one specific word. So like if I had a set of commands, go outside, play a game of soccer, and come back in, I could call this morning routine. And now morning routine is a function. And then every morning, I could call morning routine, I'm going to comment this out, morning routine, like this. And if morning routine was defined up here, if I actually did define morning routine, it would call morning routine, execute every single command within morning routine, and then end. Now, I made this function complicated where I gave it a value inside these parentheses. Now, that basically means when you call the function, it expects a value to be given to it. So if I call module function like this right now, if I just run module.py, actually, I'll transfer it to main.py. So if I create a function called module function, and that requires a value x to be passed in whenever the function is called. The parentheses generally calls a function. That's what parentheses are meant for. Remember, module function itself is a variable. So I can set module function equals to 2 right now if I wanted to. But module function is a variable that's of type function right now because of how I've defined it. So if I want to run module function, I will use parentheses. Now, this might be familiar from something we talked about earlier, which is called the print statement. The print statement, you'll see it follows the same format as how a function is called. This is the name of the function. You have the parentheses that are saying you basically want to run the function, and then you have something inside it. Now, how print would be defined if print were a function, which it is, would be something like this. Def print of what to print. And then now inside here, I'm going to put pass, which is the keyword for do nothing. But basically here, it's going to print the value of what to print to the console. By the way, the console is this entire thing, as you can see with the console tab. That's basically your output when you're running a file, or a Python script, or any other script, whatever you want to run. So this is how print works. This what to print is a parameter. Whenever the print function is called, it expects a parameter what to print to be passed in. So that's why when I print this string dash dash is the parameter that it wants to be passed in. If I call print with nothing, it works because of a special way to make parameters optional. But it expects a parameter of a string or a number or something inside the print statement that it needs to print. That's how print is defined. Now, if you look at module function, you'll see that module function wants a value of x, and it's going to return x plus 5. Now, if you don't give it the value of x, module function doesn't have an important variable that it needs, so it will not run. Type error. Module function, the function that I defined, is missing one required argument, x. This is basically telling you when you're calling module function in line 20, the function needs an argument called x. And when you call it in line 20, you never gave it a value for x. So now, if I give it the value of 5, it'll run correctly, because now I've given it a value for it to treat as x. Return is basically what the function gives back. So a function can just be like a specific set of commands that it runs, right? Now, after the commands, the function has an opportunity to give back the result of commands. Obviously, you can give this back by just printing something within the function, right? Like you can print x plus 5 within the function, and now if you call it, it's just going to print 10, because 5 is going to be passed into module function. Now, module function takes in 5 and prints the value of 5 plus 5, which is 10. But the return statement is special in that it returns the value of x plus 5, which means now if I say y equals to module function, what module function is going to do is it's going to pass in the value of 5 as x. Module function is going to calculate what x plus 5 is, which in this case is 10, and it's going to return the value of 10 as whatever it will be normally. So remember how we talked about earlier about x less than 1 if x is defined, x equals 0. If x is less than 1, remember how this specific expression either gives you a true or a false. If this specific expression gives you a true or a false, you'll know this specific function gives you the value of whatever you give it plus 5. That's how you should think of this. So basically, now what this lets you do is it lets you do more stuff with y, like y equals y minus 5, which is basically equal to y minus equals 5. They're identical. And then you can do more stuff with it and then print it or do whatever you want with it. So a function can return stuff like this for further processing. That's what this function is. That's just a quick overview of functions. Now, you can see that in module function, I just created in module.py, which is a separate Python file, I've created a function, and I have a few print statements at the start and end of when it's run. Now I'm going to remove this calling line because that's going to throw an error. It needs a value inside it, obviously. Now, the way you would run this is just like how I would run Python main.py. Here I can run Python module.py, and this will run everything. Basically, it'll print the import. It'll define a function. It's not running it. It's defining module function as a variable that's equivalent to a function that returns this value, and then it's going to print this at the end. Now, you generally want to, if you're working on a large Python project, you want to split up your code into multiple files. Now you can see here main.py is the main file that runs, and I also have main.py configured as the file that gets run whenever I press the run button. So now, what if I want to access module function from module.py? Remember how I told you about scope and the fact that module function is technically a variable, and it'll only be accessible within module.py. So when module.py starts running, it'll run everything, it'll create the function, it'll run everything, it'll print this, and then once the file is over, it's not defined anymore. Module function doesn't exist. If I go here to main, I'll remove all these lines for now, and instead of doing any of this, if I just do module function and I give it 5, for example, it doesn't recognize this. undefined name module function because it doesn't know what module function is because it's in a separate file. Now, what you can do to link files together is called an import. Import module. Now, you can import a module like this. Now, module, Python knows that module refers to this specific file module.py. And now, obviously, you can use file system like relative tracks. So, if you want to go a folder back, you can go /module. Obviously, it knows this file does not exist, but ideally, you can go /module, and it'll import the module file that's within the directory above this. And you can also go within folder directories, like import template.module. And now it'll try to access the module file within the template directory if there was a folder called template here. Now, basically what I'm doing here is I'm importing the module file. Now, I have access to everything inside module. When it imports a file, it runs the entire file, takes care of it, and it stores all of these and gives you access to everything within here. But when you import module like this, you have to specify that module function is not something within main.py. It's something you're accessing from module.py. So you'd say module.module function of 5. Now, since it knows what module is, since you're importing it, it knows module refers to this specific file. Dot is basically a reference here, saying the module function within module. And module function is within the module file. So you can call module function, and obviously it requires a parameter. And since module function returns something, I can set x equals to this, and I can print the value of x. Now, when you call module.module function, x will store the value of 10 because it's as if you now have access to the function over here. And when you print x, it will print 10. Now, you can see in line 1, when it imports the module, it runs the entire file, which is why you see these two lines. Importing the module has begun, and the module has finished importing. These two lines are printed whenever the file is imported because it runs the entire file, and then it imports it. Now, another way to do this, there's a keyword you can use called as. Obviously, these keywords, import and as, you cannot name as variables, and there's a giant list that's available on the Python docs. Now, if you import module as m, now it knows that whenever you use the value m, you're talking about module. So you're basically setting m equals to module. So now instead of saying module.module function, you can say m.module function, and it knows m references module, and module has a module function. And obviously, this is still going to print your two print statements for importing, and then it's going to print 10. Another thing you can do is called from, which specifically lets you import specific things from it. So from module, which is this file, I want to import just module function. So now it's not going to, if there are multiple functions defined within here, like say I have defined module function 2, module function 3, and other functions like this, it's only going to take module, obviously it has to run the file, but it's only going to take module function from this file and make it accessible in my main file. Which means now I do not need to reference specifically what module function I'm talking about, because now I know that the module function is the function that's from the module file. And this will also do the exact same thing and print 10. Another common thing you can probably see, although this is not recommended by Python, is using star. Now, star basically stands for everything. It also stands for unpack, but that's a very advanced use. So from module import star means from the module file, import everything. So if there were multiple functions defined here, define module function 2, it'll import module function 2, all these functions into the main file. So obviously module function is still accessible. And as you can see, they're all underlined green because now the entire interpreter, the entire IDE is confused. Module function may be undefined or defined from star imports. It does not know specifically where module function is from, but it knows that you're doing a star import, which means you're importing everything from this file. So it's saying the module function, I don't know exactly where module function comes from, but it could come from the fact that you imported everything from module, which is why it's not recommended to use this. As you can see, over here it says the from module import star is used, so it's unable to detect undefined names. It doesn't know whether module function is defined or not. But this will still work because it's importing module function from module, even though it's importing everything from it. So it's recommended to import certain names from your files. This is how you spread out your files throughout everything. And if you had multiple module functions like that and like that, obviously these are not defined right now, but it'll know exactly which functions you want to import from this file, and then it'll be able to import those. So that's about it. This is a basic introduction to Python, how variables work, how conditionals work, if statements, else statements, how loops work, like for loops, while loops, a basic intro to functions. There's so much more to explore with functions, but I couldn't cover all of it in our introductory workshop. And finally, modules to help you get started with whatever sort of files are going to be interacting with your Python application. Now, if you have any other questions about this, you can feel free to ask on the Discord server. I'll be online and ready to answer any questions you have about Python. You can also just talk about it in our Python channel. And yeah, have a great time hacking at Next Step Hacks.